A new store must hire 3 cashiers and 4 store clerks. So this is titled Solving a Problem That Involves More Than One Combination. So it kind of connects the spaces technique you learned in the fundamental counting principle to combinations. Because here they need to hire cashiers and store clerks. So there's basically 2 decisions that need to be made. You need to hire cashiers and you need to hire clerks. Now, how many choices do we have for hiring cashiers? Well, there's 7 cashiers and we have to hire 3. The order wouldn't matter. So the number of choices for cashiers would be 7, choose 3. The number of choices for clerks would be 8, choose 4. These aren't separate cases. We don't add them together. They're separate decisions that need to be made. And for every group of 3 cashiers that we hire, that group of 3 could mix with any of the group of 4 clerks that we could hire. And so we multiply them together to get our total. Now, sometimes you'll see this question in a non-calculator multiple choice. On a non-calculator multiple choice, it could look like this is the final answer. It could also look, right? This one is 7 factorial over 3 factorial, 4 factorial. And this one is 8 factorial over 4 factorial, 4 factorial. So I've seen it written as a multiple choice question where they've just combined all of this together. It would just be written like that. That's how I've seen it as a multiple choice question. If it was non-calculator, I'd cancel all those things out. You could, right, start canceling and see if it is something that ends up in mental math stages. But, well, do you want to do it just for fun? Right? If I expand 7 factorial until I get to 4 factorial, and if I expand 8 factorial until I get to 4 factorial, I have on the bottom 3 factorial, 4 factorial, 4 factorial, 4 factorial. Those 2 4 factorials would cancel out. Then I have 7 times 6 times 5 times 8 times 7 times 6 times 5 left on the bottom. And here I would have 3 times 2 times 1 and 4 times 3 times 2 times 1. So what can I cancel? Well, 4 and 2 make 8. 3 and 2 make 6. I have another 3. So that could simplify to 2 over 1. So what am I left with on top? Is it fairly easy to do this by in our head? 7 times 2 times 5 times 7 times 5. Not impossible. Okay? If I was doing this in my head, I'd probably put the 2 and the 5 together to make 10. The 7 and the 7 together to get 49 times 5 times 10. 49 times 5 isn't too bad. 245 times 10. 2,450. Not too bad. So you could do it without a calculator, but this would most likely be, if you had to calculate the final answer, it would be listed on a calculator part. Okay, questions for practice on this one? 12, 13, 14, 15, 16. Okay. And do we have time to do 15 together? I think we do. Let's do part of 15 together. So the reason I want to do 15 together Oops, wrong one. Is because sometimes 15 on a test they ask you to do it algebraically, and sometimes in 15 you can do it not algebraically. So we're going to look at 15a in particular. They would ask you to do it algebraically. So n choose 2, you would go to your formula sheet and say n choose 2, well that would be n factorial over 2 factorial, and what always goes beside it? What would you have to add 2 plus what makes n? n minus 2 equals 28. So with factorials with variables, you always expand the bigger one. In this case, which is bigger, n or n minus 2? N. Start expanding the bigger one until you get to the smaller one. Here we are, n minus 2, so that it cancels out. With the n minus 2 on the bottom. And so we're left with n squared minus n. What should I do with that fact that there's all over 2 on the left side? Because this will be all over 2 equals 28. Multiply both sides by 2. It's a quadratic, so we make one side equal to 0. And you can factor. It'll be minus 8 plus 7. Okay? On your final exam, when you solve it, you need to show that this one is not possible. You need to put an X through it. It is not okay just to write one answer and not show the other answer with an X through it. They take off a half a mark for that on your final exam. Show that you understand that you can't have a negative factorial. The only answer is n equals 8. For the other ones, they wouldn't be algebraic. You could guess and check.